negative marking. Okay, negative mark. Okay, I think that should be there. And since all you are, doing some mischief, so for 3 questions, 30 minutes, 10 minutes maximum, because this is that you are, JEE, a bigger exam you have qualified, you have cracked JEE, so you are capable of doing everything. And the questions are, the linear programming is very easy, very, very easy, and you are the master. Okay, so many tables, I hope you have remembered, and I will take an extra class. If any doubt, you can explain me. Okay, so that's all. So about the interior point, one part I have given, which has come in the textbook. Textbook part I have given. There something was written, I have borrowed from the net and I have given. So how the the interior point method was known, who has developed, how how it become popular. In 84, it became very popular. Actually, I joined during the period, 83, 84, something like that. One, because all the teachers, mathematics, computer, all our management, all are trying, how to implement his software. Okay, how to implement. And that time programming was there, so like basic or Fortran. Even C was not there. Okay, C was, people just like, Python, they were in trying stage. Some professors from our department told you are working on optimization. So most likely you will be capable of, to develop a code in Fortran. So for our department. So because the professor who asked, he introduced mathematics computing our department. Professor Guru Prasad Bhattacharya, he is still alive. So and they have mind, how to and make the mathematics people, capable of doing everything. Even earlier, I'm telling, when I was scholar, I was trying to attend the computer science department, some course. They are not allowing. Something like we are SCST type, they are not allowing. Even the electronics people, they are not allowing to attend their, I just try to attend a course like computer digital fundamentals. One Joseph from Kerala, he was taking the class, he didn't allow. He told, no, mathematics schools are not allowed. This is, something higher. So we are crying. So what you are not allowing, at least for the, for your the introduction, at least we'll get some job. Mathematics people are not getting job. And only, the science also, chemistry, physics, geology, they are getting job. Where? In geophysics, in oil company, this, that. We have no job, nothing. And only two types of job are available. One was in ISRO, another was the DRDO. And both I qualified because due to the hard work, we are capable of implementing many things. First, I qualified the interim, where the, Kalam was studying the missiles from Balasore. I actually from Balasore. So I have a house in Bhubaneswar. So I got selected there, but I could not join. In the meantime, I got IIT faculty position here. And also I got this ISRO Ahmedabad scientist. One is B, another C after just PhD. So I could not join ISRO also because it is very far, Ahmedabad. ISRO Ahmedabad I was selected. So one of my friends, just 12 o'clock midnight, he called me. He told me, you are at 2 o'clock you are working. So what is the problem? I told you, a lot of students are there, 400 students. I have to prepare plan and I have to talk something. So he is SBC Sastri. He was there in ISRO. He left the job and settled in US. Not only in US, his daughter, brother, sister, everybody. He is from Hyderabad. And he told, why don't you come? Then he suggested me, you send your son, daughters, I will take care. I told, if they qualify, they got fellowship, they can, then I can, but I cannot, IIT professor cannot send children to US just like that, unless you get fellowship. My daughter qualified, he got fellowship from the Iowa State University and completed PhD in 5 years. She is the faculty now there. And my son told, yes, I should also go. Daughter is from the computer science. Son told, okay, he is from electronics. I should also go. He qualified and he is now in faculty research scholar at the University of California, Santa Barbara. So before that, my wife has completed PhD in statistics. I have completed in mathematics, optimization. My daughter in computer science, my son in. So because see, most of the problem, whatever I cannot solve, I used to give the hints, you just solve it. So then solve there, they solve generally my problem. He told, no problem, don't worry. See, many facilities, what I was telling you about the Python. Why Python? See, so many languages here. Python, Python can eat anybody. That is, basic, Fortran, C, C++, Java, so many things, Python. So Python is the present day language. Everybody should, okay, Python. And I don't know, when the name in the language is Python, what you have in mind? Possibly, the biggest, I can say that, everything you can do using Python is scientific computing, okay? So I'm sure you must have started many, I have given the code, on Karmakar's interior point, that algorithm I have given to only three students who were interested and asked me. Rest they are not interested and not asked. But still I want to show what is there, why I cannot give. So we'll discuss just a little about the interior point method. And you see, you may not be able to write a code for the simplex method, dual simplex method, revised simplex method, big M method. They are little complicated. But suddenly, if you try, you will be able to write code for the interior point method. So easy. Only matrix inversion and some iteration process. Okay. It is very easy to translate. Very easy to translate. So now let us know, say what is there in the Karmakar's interior point method. So just 5 minutes I will complete and will come to the model, what duality theory was to us. Okay. There is the new polynomial time algorithm for linear programming problem. Why time algorithm? It is given in the very beginning. So we present a new polynomial time algorithm for linear programming. In worst case, the computer science students, understand very much what is the complexity time algorithm, etc., runtime, etc. So other people's, it is something, something like, you have to learn. Okay, you have to learn. Okay, I'm coming directly problem. See, can you see the problem? Minimize C transpose X subject to X equal to 0 and sum of the components equal to 1. X is greater than or equal to 0. Okay, this is the problem. Is it a linear programming problem? Is it a linear programming problem? Have you solved this type of problem? So many problems solved. Okay. See, this paper was presented in 84 conference, and it was available. That manuscript is available, so I got in 84 that manuscript also. But this paper, it came to journal maybe after 2-3 years. So then recently, I could download because the library, they are subscribing this type of journals. Earlier, that thing was not there. If they feel that yes, you are a genuine research scholar, genuine student, so and I got the original paper from the Karmakar, the original paper is there. Okay, just like a small book type. But now my question to everybody, is it looks like a linear programming problem, what we have stated? Is it looking a linear programming problem? Yes or no? Are you able to hear, gentlemen? Anuranjan?
Yes, sir.
Anuranjan Sarkar?
Yes, sir.
Anuranjan Sarkar is happened to be my supervisor's grandson. He told me, sir, I am your supervisor grandson. I am very much interested. Okay. He is really interested, but Anuranjan is there. Anuranjan?
Yes, sir.
Okay, very good. See, he is there. I cannot see why I'm saying people are interested, people are not interested. If you are interested, you can do something. If you are not interested, what you will do? You will not do anything. And you will search for job only 1 crore, 1 crore. You don't need 1 crore. For surviving, you need only, nowadays you need only 1 lakh. Per month, 1 lakh means it is a very good job. Okay. But some of your classmates, those who could not qualify job, this, that, even they cannot get 5,000 per month. They cannot, I'm telling you, I'm sure. So if you're getting 1 lakh, you should be very happy. So you can do many things. India, outside, okay. But suddenly 1 lakh is a big amount. So be happy with that. But suddenly you should do something. You should contribute something for your friends, society, to the government of India, etc. Because they are saying many times, you have, which our institute is 75-year-olds. What you have done, you tell me in one line. What you have done? See, if you see that way, we have done many things, and if you see that way, we have not done anything for the public. That is the reason we are poor. That is the reason many people are begging in the train, begging in the road, this, that. Some parents are begging. What they are begging? My children are not supporting. My children are not supporting. Then why? That is the reason they are begging. But you should not do that. I am telling you should read, you should earn, you should distribute, and make your life, make your community, make your village, make your city beautiful. Okay. Why I'm saying you should do it. You should learn it. It is required. Not that you should borrow. And you should write in a separate manner. You see, somebody is using X, somebody is writing without seeing his program. Again, you will write X, how? Somebody is writing N, somebody is writing, not that. See, when the people copy, I have seen people copy program, even your roll number will copy. If Anuranjan is copying, see, or somebody has copied from the Anuranjan, his roll number also copied. If roll number is copied, so what we understand? Means you have copied totally without, blindly you have copied. See, one will develop program and they will distribute 100 students. And even whoever distributed, he should also get 0. I'm telling. You should get 0, my policy. But if you are doing all well, and because we want to test it, how will test? Randomly you will collect students, we ask a question. We have plenty of questions because you have seen I have created so many problems. I will ask you make a table and they explain me the table. So if you have enough time, solve as much, at least 10 problem for each section. Okay. If you can do like this, suddenly I'm sure you will get full mark. You are capable of getting excellent. But if you will not do like that, so see, for passing, there is no problem. For passing, there is no problem. 30 marks. 30 mark, 5, you are getting means you will get 30. And I am not cruel that I will fail you. I will pass everybody, no problem. But I will not give excellent to everybody, or I will not give C to everybody. So I will give according to your work. Even if you are appearing online, I have told, I have given a group. The group will develop a code. There are 10 programs. So the group will distribute the complete 10 program. Each student will at least 1/5 they will do it. 1/5 of the work. Okay. So now tell me whether it is a linear programming problem or not. If it is a linear programming problem, then how will solve? Anybody? Why? What is the problem? Tell me.
Sir, it is a linear programming problem with equality type constraint.
Is it a linear programming problem? Linear programming problem say the objective function is linear, constants are linear, Dasson variables are non-negative. So it can be maximization type, it can be minimization type, constants can be equal type, constant less than equal type, or constant greater than equal type, etc. Is it a linear programming problem now?
Yes, sir.
Yes, it is a linear programming problem. So how this thing happened? See, whatever problem we solve, we have never seen the variable, sum of the variable equal to 1. So by some technique, it has been normalized. All these components, they are sum equal to 1. Non-negative. Non-negative means, in the positive side. So if it is there are say 4 quadrants. So in first quadrant, you want to find the solution. If there are suppose 8, then the octant, first octant, okay, you will get the solution. So, and sum of, for example, I'm saying x1 plus x2 plus x3 equal to 1. So interior points, so none of them can be 0. Something like x1 is positive, x2 is positive, x3 is positive. For example, half, 1/3, then half plus 1/3 equal to 5/6, then 1/6. Half, 1/3, 1/6. So how many ways you can find this set? How many ways? Tell me. 3 numbers are there, x1, x2, x3. 3 factorial? 3
Yes,
factorial? 6 ways, isn't it? Yes or no? See, you have taken input half, 1/3, 1/6. Somebody will take 1/3, half, 1/6. Say like that. One is fixed like that, 6. So, for example, there are n numbers are there, x1, x2, up to xn. how many? So sum equal to 1. How many way we can select the interior point? If you are selecting something infinite, certainly, but here x1 is fixed. Let us say you want to fix something like half, 1/3, 1/6. Similarly, x1 plus x2, x1 is fixed, x2 is fixed, xn is fixed. So n values, okay. Again, x1, x2, x3, their position can be changed also. Value can change. So n factorial. If n equal to 5, how many? How many number will come? Yes. How many?
So 120.
5 factorial. And if it is 10, how many?
10 factorial.
So if you are 100, so you have to see giving data also difficult. Giving data equal to difficult. So what do we do? If it is 5, say very cautiously we will start with the center 1/5, 1/5, 1/5, all 1/5. 5. Okay. Here 1/3, 1/3, 1/3, 1. Here it is n 1/1, 1/n, 1/1, like that. Okay. Center. Because giving data is easier. Okay. Giving data is easier. But if you are really, it is true for any, you want to experiment, so you can give anything. Okay. So what I'm saying here, interior point, you will start with the interior point. In the simplex, we start the solution from where? From an extreme point. From an extreme point. There are, suppose in a problem, there are 4 extreme points. First extreme point, let us say the origin 0. Second is, let us say x1, then x1 vector. Third is x2 vector. Fourth is x4 vector. Let us say x3 vector. Say x0, x1, x2, x3. 4 points are there. So we will move in a manner from here, x0 to x1, x1 to x2, x2 to x3, like that, or x1 to x3, x3 to like that, some manner. But you cannot jump directly from 0 to x0 to x2. It will move in a manner. That is the reason so many tables are coming. Okay, but I'm telling there is no guarantee that the problem will converge in simplex. But here in interior point, there is a guarantee that it will converge. In simplex, there is a beautiful thing. So what is that? Whether the problem has infinitely many solutions or not, we can find. But from here, you cannot find whether it has infinitely many solutions or not, because you have taken a starting point. Okay, so it will converge at the output point. So it depends on your input, it is converging. Okay, so one input cannot conclude anything. Okay, but you need a solution. Solution means what is the minimum value or what is the maximum value? Minimum value is important for us. Okay, so it may have also infinitely many solutions, because according to the linear programming, a linear programming problem either infeasible or feasible. If it is feasible, then one optimal solution or infinitely many solutions. Okay, that's all. This is the problem. Now the question is how you can convert this a linear programming problem. This is a standard form. This form, whatever is given, it is called canonical form. Canonical. So any problem is given, you have to change to this minimization type, a canonical form. Okay, I will give hints how to. So many things are there. You have to read carefully. I am telling the working procedure, how to transform the problem to canonical form. Okay. These are the theory, because it's a lot of mathematics. Our scientist Kormakar may be a very good mathematician, very good mathematician. Now see the transformation. The duality theory we have studied. This is the primal one. Primal can be maximization type, can be minimization type. Maximizing primal will be minimizing dual. Minimizing primal, maximizing dual. Yes or no? This is given, let us say, primal. Why primal here started with maximization? Because the original problem is minimization. Because the canonical, he is writing code for the canonical, but nobody has the canonical form. We have a linear programming problem, so that you have to change to canonical, then you have to apply the algorithm. Let us say this is minimization is primal. The dual will be how much? If this is minimization, dual will be maximizing. That is C transpose X, is B transpose U. Okay, and what is that? X A transpose U less than or equal to C. Okay. For our simplicity, take a maximization problem, because I am solving maximization problem. Find the dual and you merge it. If you merge, see, if it has optimal solution, maximization of the primal, here it is minimization of the primal, is same as maximizing the dual. That is the, okay, both are equal. That is the strong duality theorem. According to that, CXT, C transpose X, that is the primal objective function value, minus B transpose U, that is dual objective function value, their sum equal to 0. And this X is non-negative, primal is non-negative, U is non-negative, because the first model say, there are 4 models, only one model we have discussed. Second, third, fourth model we have not touched. Yes or no? Is there any problem to say yes? At least a dozen of people should say yes. Yes or no?
Yes, sir.
Yes, sir.
Okay,
Sir,
X
yes,
is
sir.
primal, U is, because we write something like X and Y. Okay, these gentlemen writing X and U. See, X and Y I told, X is primal is, let us say, male, Y is female. If X is female, Y is male. Okay. See, sometimes X is dominating Y. Dominating means, so dominating means the more members are there. Sometimes other more members. Okay. Members means you can say that, what is that? Activity or something like whatever, maybe you can say that components, their activities. Okay. So X and U, X and U or X and U, Y. Okay. Y, what is Y? Y is the, according to their problem, Y nothing but the lambda. Lambdas are the multipliers. The multipliers are nothing but the dual variables. Anuranjan? Anuranjan, hello?
Yes, sir.
Dual variable.
Yes.
Multipliers. So the Lagrange method of multipliers, it is given in the Piskunov book. It is given in the certainly not there in the Krajcik book. Okay, it is there in calculus. Okay, in some book it is there, some book is not there. But it is there in the Piskunov book. Piskunov, they are teaching from the Piskunov. You
Yes,
attend the
sir.
class, no? Piskunov or
Yes.
Sanjana? Okay. See, Piskunov is a very small book, but gives all the fundamentals. Okay. A poor student, he can also understand, and a rich student also can understand. Okay. But very elementary level it is written. But it's very good book. Okay. But you have to understand the philosophy of the book. Piskunov, a Russian author book we are teaching. Nowadays, the younger people, I have never, so many years I am not teaching the mathematics 1 or 2 because the other, to teach the OR programming, the other teachers are not there. The younger people are teaching, and they teach mathematics 1, mathematics 2, mathematics 1, mathematics 2 for whole life. But we teach others because, see, I am a mathematician. I started learning the statistics because statistics people are less. Earlier, we were teaching statistics. Okay. So then some statistics people retired. Okay, then they told you cannot teach statistics. I told yes, it is possible, easier. Actually, statistics is an easier subject than mathematics. But statistics has many concepts. Many concepts. Okay, something like degrees of freedom. You have read statistics? Yes or no?
Yes, sir.
Yes, sir.
I think in the last time. Okay, those have not read statistics. You ask me, I will tell you, give a book. So if you are going for machine learning, you will be master in linear programming, nonlinear programming. Nonlinear programming, I will not be able to cover, but all people, if you like, I can cover in a very big manner, maybe in 7 days. Okay, I will certainly cover because so many people are very much interested in optimization, linear programming, nonlinear programming. We are solving only linear. Then other side, generally in machine learning, both problems are there. Okay. Least square method. You know least square method. Least square method. Have you heard the name?
Yes, sir.
If you open any machine learning book, then you will find least square method. So from the data, you have to estimate something like a surface or a curve, etc. Once the right curve, right surface is established, it's done. Machine has recognized what is that. Okay. So I'm telling here. So for example, more equation, less variables. More variable, less equation, certainly you can something, but more equation, less variables. You can estimate, some They are called over-determined system. More equation, less number of variables. Let us say 10 equation, 5 variables. Of course, they are independent. Some error will come, and that error we have to minimize. Minimizing error using least square method. Okay, simple thing is estimating a line in the form y equal to a plus bx, was estimating a parabolic curve, estimating a cubic curve, estimating a polynomial, etc. We use least square. Okay, so everybody, those who are learning machine learning subject, those are going through, you should be thorough about the least square method. The least square method is there in mathematics, in statistics, in computer science, in machine learning also. Everywhere least square method. Okay, and see, if you open the Krajcik book, you have the Krajcik book or you have thrown? Anybody? If you have thrown Krajcik book, again you have to purchase. So see, if somebody there a CEO, no, so he will tell that show me your Krajcik book, which volume we had, if you have studied. So it is a very beautiful book for all the engineers. Basic knowledge, what you need must be there. Most you should learn, and such book you should not throw it. And see, of course, there was no communication on Saraswati Puja day, so that was on Saturday. We believe, all the students believe, all the teacher believe Gayatri mantra. Yes or no? See, I'm telling, see, I'm not Hindu or Muslim, this, that, but everybody, you see, everybody, and believe on the Mahamrityunjay mantra. Yes or no? During Corona times, all were saying, okay, only the mantra will help. Medicine will not help. See, they say the first dose you take, Corona you over. Second dose, then third dose, then fourth dose. Then they are saying every 6 months you have to take dose. I don't know how many doses you will take. Whether after that you are safer, we will be safe or not, that we cannot say. So like that. But mantra will keep you safer. I'm telling. See, when you play mantra, not in mobile, put a system like that. Nowadays, all the Chinese systems are available. So in a very slow language, it will play sometimes in whole night and whole day. If it is required, there is no problem. But this you will, your fear will go. You will not fear to this Corona, and suddenly you will do the duty. You will not move around. Our life is more spacious. I have seen marriage is over. Husband, wife, one of them died within 2 days. Such a pathetic situation. So we think maybe our turn will come next day. During last June only. So like that. So much fear. Okay, even somebody saying, no, I cannot touch somebody's feet because Corona will come, then sir will suffer, this, that. It happened. Even, people are not going. So I was once by mistake, I raised my hand for handshake to a neighbor. He got angry. He told, that it's Corona. You cannot. I told them, sorry, I have forgotten. Okay, so it may happen. So something like when you meet a friend, boy or girl, we say good morning, good evening. Why? Because it is an instant things we have learned. Okay, or namaskar. So see, we cannot even do everybody. You cannot say namaskar. The maid servant is entering. Suddenly he opened the door. Namaskar, not that. Okay, you have to smile. Okay, but to everybody you cannot, because they will sometimes you will get angry. Okay, but what I'm saying here. So when you learning a subject, you learn properly. Learn how to solve. Learn how to ask post question, right question, wrong question. If you cannot justify it is a right question or wrong question, and you are not attending class regularly, so you think you are doing a crime. See, every morning you get up, inform your parents, yes, I am here in the class, I am going to class. But you see, parents call you, that is pathetic. That is pathetic. See, I was entering, there was a phone call from my son, yes. So I told, I am just going to class. I told, okay, so have you got your mail, etc.? Yes, I got. Okay, and sometimes he keeps track what I'm doing in the midnight. Okay, because if I'm preparing a note, you see, because I'm online, I'm sending a mail, generally mail to A, B, C. Then what? Somebody send mail at 4 o'clock. There is a time they inform the time. When somebody say you are not sleeping, you are writing mail at 4 o'clock to me. See, sometimes, you know, all this type of work, teaching, or you are preparing some document, or you are applying somebody's query. So the after, you know, after 3 o'clock, 4 o'clock, 5 o'clock, you know, you have to do. After 7 o'clock, certainly you cannot do it. Certainly, I'm sure. Okay. So what I'm saying here, so don't sleep for 8 hours, 9 hours, 10 hours without informing your parents, without informing. And sometimes, you know, you have a mobile, you have a WhatsApp number, you never check. Even there is a phone call also, you never leave. Actually, that is a crime. Knowingly you are not replying. Okay, you switch off, then all right, fine. So you know that mobile is switch off. It is ringing, but you will not lift. Okay, so then it is a crime. I'm telling many people, you know, when they don't leave the phone. I used to ask them, are you going to toilet? Yes or no? Toilets take more time, but lifting phone, it take 2 seconds. Okay, yes, I'm busy later on. Okay, no need of sending. Lift, say yes, I'm busy. Okay, but what I'm saying here, so you have to respond. In this class, you have to attend 8 hour class. So I don't know, in the January, it was really very cold. Okay, so really very cold, but now the weather is very good. Yeah, and you can prepare well, you can study well, and you can also plan what you can do in coming month. Or see, it may happen you will have attend class, and your test will be offline mode. So in the Nalanda there will be test, so will conduct. It may happen. So prepare accordingly, but don't think that always there will be online, so and you can borrow and you can copy. Okay, this is the primal, dual, combine. Then introduce slack surplus variables. See, x is primal variable, u is, what is that? X is primal variable, u is dual variable, and here y is different. Y is a surplus variable, b is slack variables. See, in such problems, only in the simplex case, the artificial variable comes to picture. In case of the Lagrange multiplier method, the artificial variable is not required. Okay. Equivalent type means no slack variables. Inequation means slack surplus, and slack and surplus variables are required. So these are the variables. So in my note, you have x, y. These, you know, slack surplus, I am writing something like, you know, I put s something, st something like that. Okay. So any manner you can write, introducing slash surplus variable. So you will have a and what else? And once you introduce slack surplus variable, these are 1, 2, 3 sets. You know, these are the m in number, these are n in number. This is okay, 1 in number. So m plus n plus 1. These are the equation. These many equations, and these are the variables. Okay, how to count variables? The variables are x. Let us say n in number. Then u will be it's the, you know, that u will be m in number, y is in say n, m, like that, twice n plus twice n. Okay, these many numbers. Now, but in this set there is no objective function. There is no objective function. So we have to create another rule to how to make an artificial variables. Here only one artificial variables, that is lambda. Here there lambda is multipliers. Here, okay, so we have the multipliers. Here also similarly you can say this is also a multipliers. So, and also we are talking about the artificial variable. So introduce artificial variable to create an interior starting point. There is a trick I have to explain with some example. This, then after changing the notation, this is something like C transpose X and is subject to X equal to B, X is non-negative. If you say only X are there, okay, this, then with respect to this problem, we have some transformation called projective transformation. You apply the transformation. If you apply the transformation, the problem will come to the canonical form. The canonical form is like this. After all the transformation, it is coming like this. This is over. This is the canonical form. This is any linear type problem. This is the any linear type problem. Okay. Okay. This you want to make it canonical. Canonical is here. Okay. So we have to explain by means of example this canonical. So once canonical is over, our actual algorithm. What is the actual algorithm? I'm coming to the algorithm. Karmakar's algorithm say like this. See here. Okay. Choose the center point. You know, the center of the simplex, that is the for the canonical form. Okay. Some steps, you know, whether the point is feasible or infeasible. Check for infeasibility. Check for optimality. Here there is a step. You will find something like B equal to A into D. D is a diagonal matrix. A is the what you have formulated, and E is a vector, all having all the element 1. So 1 1 1. So it's transpose a row vector. So B. Then we will develop some steps. But actually, finally, what are we doing? We are computing the inverse of the B. Okay, inverse of the B. This is, you know, many things are not there. They are there. I have not discussed. Say what we want. We are computing the, you know, these are the steps. Your Python will help you to implement. But which, what exactly we are doing? We are computing the inverse in a very specific manner. That is given here. Okay, this already we have discussed. This, the computation of inverse, the in the paper, that is the 6.1. So actually B is something like AD and the transpose B. B into B transpose, this is the matrix. Okay, and we are finding the B into B transpose. Okay, this is inverse. So what you are doing? You are using this code. Okay, so A transpose C is inverse. This is the steps. So what I'm asking, everybody should read first how to compute the first inverse, the 6. That is 6.1, 2, 3, 4, etc. up to I will tell you section 3, section 6 up to 6. After that, nothing is there. Okay, then it's conclusion. So how to implement? So this work, you don't do all this checking. You do only the implementation. Okay, only the implementation. Okay, and since the duality theory you have not covered properly, and there is included in the test, I am going to that duality theory. Okay. See here, how many models, how many dual problems we are considering? The 4 type, according to. There are several types. So using these 4 types, I can cover everything. Okay, 4 types. First type, this. You remember this first type? Maximization type auxiliary function, constants are this. Okay, but in the Karmakar's paper, it is given what, which one? Which one? Is not first, neither first nor second nor third. It is given minimization type of this. The number one's dual. Number one's dual is given. If that is dual given, then this I will be primal. Okay, this. The primal I am presenting, he has presented dual. Okay, this. This I have already told. What is the dual? Dual is this, you can see. This is the primal. Dual is this. In the expansion notation, this is the dual. Okay, yes or no? Actually, in the Karmakar's paper, this is primal. This is the primal, that is dual. If one problem is primal, other is primal is pre, dual is dual. If you are thinking D is the primal, then P is the dual. Vice versa. Okay. So P is primal, D is dual. If you says D to primal, then P will be dual. This already I have discussed. I am not repeating. So we'll come to model 2. Model 2. Some examples. This also we have discussed. I am not repeating. This slide you got I have sent to everybody. You got it? Yes or no? I will make.
Yes, sir.
Yes, sir.
all.
Yes, sir.
Yes, but after taking the slides, simply don't dump in your computer. You read at least and derive yourself. If you derive, then you will understand. This, what is there? What is the difference between first model and second model? Anybody can say? Difference between first model and second model.
The constraint here is equality type
Equality type.
in the first one.
If constants are
less than-
equality type, we will have also dual variables. The dual variables are free. If constants are equality type, dual variables are free. Okay, if dual variables are free, constants will be equality type. Okay, in primal, okay, something like that, vice versa. So here, with respect to P, say what is the dual? Dual will be in mathematical notation, dual will be like this. Because two form, one is in matrix notation we are presenting, and without matrix notation, without using matrix notation. Okay, that is better. In the expanded form, dual will be minimize f dash, I varies from 1 to m, bi, yi. This y1, y2 up to ym, these are the multipliers, Lagrange multipliers. Okay, and this y I we are saying lambda I. That is the reason say yi is free. Okay, and constants are in the primal less than equal type, in duality greater than equal type. This is the dual. So this, what I want to say, should I tell all this step how to derive, or you can do yourself? Should I tell? If you tell quickly, I can cover. Otherwise, I will go to the problem. I am covering because it is required. This you will not find in the textbook. Okay. So when I was teaching, for 10 years I was teaching without the proof. I could not find in the any book. So they thought it is very easy. Because most of the students in my class, they are asking, sir, from where you can derive? We know that it's primarily dual like that, but how can you derive? So then I realized, yes, that trick I have to understand. So how it is, they are also, all are thinking it is something like implied, not implied. Not implied. Okay. See, earlier, when you are born, so after, certain age, parents decided, okay, I have to plan for my son's marriage, daughter's marriage. Okay. It is, they are saying it is, no, I have to arrange. It is implied. Now, it is not implied. Okay. Without, marriage, people are saying it's, baby. Okay. That is also something like that. See, so you have to marry. So something we are saying primal dual. Okay. But this you have to, how we have derived. So we should know, you should understand. But all the, earlier rules gone. So even parents sometimes will not tell you what is your plan. So whether I should go for your marriage or not. No, what you are learning from the society, you are same thing you are doing. So most of the Bollywood stars, you know that. So they don't declare, okay, so whether married or not, but they have children. Okay, they have children like that. And it is giving impact to the society. What the Bollywood people see, they are earning in crores. But when they are dying, they are begging. You must have seen. So, but I'm saying here, you need not earn in crore. Save something, whatever you're earning, and don't distribute, don't pay more tax. So don't do many absurd activity, but do the proper things, proper things so that, so you will not beg. You will not beg. I'm telling, if my parents are at distress, that will be the impact. At the end, you have to beg. Many students, so what they do, in the first salary, they will go to the wine shop, spend 2,000 rupees for a bottle. So it is a status. When I joined in IIT, few research scholars, they asked me, you join in job, so you have to make us happy. Then I told, how to make you happy? Tell me. So I should certainly fulfill your desire. He told, can you spend 20 rupees for the beer bottle for 2 person? 20 rupees. See, that time 20 rupees means a big amount, you know. The salary of the faculty was 600 rupees only. 600 rupees means 30, how much? Tell me. This 600, 20 rupees with 1/30th. And you need, you know that to go to, if I am moving from this Kharagpur to my native place, I was paying only 6 rupees and that is 20 rupees. So this is a big amount. So I'm telling, now students are there in the tech market. So they don't bother, even they don't bother for the money. So they can spend a big amount. And some are there. They are going for tuition and means earning money for their own education. Okay, so that is also happening. So I could not find such students, but I find the students. He's a bluffer, but he asked me, sir, you pay me for 1 month 5,000 rupees. I told him it's a big amount, and you are teaching for 1 hour to a boy, and that to chemistry. Why should I pay 5,000? No, sir, it is my charge. It is my charge. So it is, you know. They think this IIT campus, you have a lot of money, you can spend like anything. It's not that. Okay, you should not do that. So I'm telling you, another thing is, see, when you purchase any item, you see the date, whether it is good or bad. Okay, so you know the quality control, what you are saying, this is statistics in the quality control. So you have to check yourself, and you know this is your own money you are spending. Okay, you should not get poison. Okay, I purchased something, that fruit for the puja, it is rotten. I discovered that it is rotten inside. So I went there, I claimed that you should return my money because this is a big amount. Say, if I am spending 100 rupees for the fruits, so I should get the money. He told, no, I cannot deny. I told, you promised me that if it is rotten, you can return me, I will give the money. But you see, then he told, okay, if it is rotten, where is the rotten part? Is it required that the rotten things should carry to tech market? Is it required? Anybody will do it? Tell me. Suddenly I have not taken. Then he told, no, I will not give money. I told you, you are not a fair person. See, you promised when I'm coming from my house to tech market. See, after you know spending some time, you are saying I will not return the money. So it is not fair. I told you, henceforward, I will not come to your shop. You are a great person. And whole life, not only whole life, your whole generation will do this type of things. Okay, your whole generation. I have seen a rickshaw puller's son is a doctor. A big scientist's son is not able to complete his education. He's taking drug. He's moving here and there. But I'm requesting everybody, don't do that. Drug is drug, and not only it will spoil you, it will spoil the whole generation, it will whole community, whole society, and you know, only the police people, they are only doing how to check drug addict. They are not doing any of. See, somebody is snatching your mobile, somebody is snatching your money, they are unable to do it. But they who are the drug addict, they are fighting. How the drug is coming. See, they are for all the work, not for this work. Since we are doing some extra notorious things, so they are behind us. So I am requesting everybody, you should not do it. You should not do it. Okay. So if you have enough money, go to the market, purchase fruits, purchase good items to eat, not drug. Okay. Right. And if you have enough money, you can distribute to the poor. Okay. To a beggar, you can say 2 rupees you can give. Nowadays, no beggar asks 2 rupees. They ask at least you give me 20 rupees. Because 2 rupees में क्या करेंगे? कुछ नहीं होगा. I have remembered I was coming from the Banaras. I gave some beggar some. He asked me, give me 50 paisa. I gave, so that time, you know, 10 paisa coins were there. 10 paisa coins are there. 10 paisa was there in a good, you know, it was all over taking. He took from me and he has thrown to the river. I told you, you took my money, why you put it in the river? Is it fair? I told, henceforward, nobody will give. Then in the same bogey, in strain bogey, no, nobody has given. You have thrown the money to the river. So you are a beggar. See, in the corona, how many beggars you can see? Recently, I was in the tech market, some Mota beggar, he was running behind me sir, give me 20 rupees. Then I told, what is the reason why you want 20 rupees? Tell me. I can walk, I have a cycle, I can go. Why you need 20 rupees? Tell me. Why? No, sir, I am not getting money to eat. You give me 20 rupees. I told, how many times you have taken me in your rickshaw from this place to that place? How many times? Recall me? Not a single time. Then why I should give? If you have taken earlier, I should. One day, somebody is coming to my house. I will go for my daughter's marriage. Can you maybe give me 200 rupees? I told, then what is your profession? No, I am a rickshaw puller. I used to take rickshaw school children, do that. But he's bluffing. What he will take with money? He will take money and he will eat drug. He will take drug or he will take wine. See, this is the way you never do it, I'm telling. Never do. And I'm telling, whenever you are coming, see, and you tell the shopkeeper, whoever is selling something, you should make the environment clean and the plates, what here is offering food, it should be also hygienic. Otherwise, you will get jaundice. Many people are getting jaundice. They don't clean it, but you have to claim, you make it clean. See, you have a, you are the students, you know, they always think that you are great and they should obey. They are obeying, but you should tell. They are not obeying the teacher, you know. You don't, you know, when you purchase something, we bargain. The cost is, the cost of a dab, it should not be more than 20 rupees. Why you are asking 40 rupees? Tell me. If a coconut cost is 40 rupees, a dab cost 20 rupees. Why should it be 40 rupees? But you see, you have to bargain. You are spending your own money and you are spending your own time. See, I am not spoiling. I am only telling that you should come to the class. Those are not coming, what they will do? They advise others not to come. They will advise the juniors not to come. Sir is a very sasta teacher and he will give you good grade, need not come. But not that. I will ask you a question whether you have learned subject, learn anything from the mathematics, learn anything from the engineering side. Okay, so that's all. If anybody you are writing code, you please send to me to my mail ID. I will give my mail ID. I have created a mail ID for you, and this creation I have learned from you. But you see, your mail ID will be something like an 4 rupees charana, something like. You say that no, not that. My mail ID is I am MP Biswal. Okay, I am MP Biswal. So that no, you can remember what I'm saying. I am MP Biswal. Okay, at @gmail.com. And I will give you the, so you can send early. Those are sending. I will check and I will note down the credit early. And if I find you are copying, so negative credit will be there if you are copying. Okay, and see, we will run the program. I will run the program, the online Python program. Before that, you check it with so many examples and submit. Submit as soon as you complete, you submit same day. Okay, complete. And what will come submit? You will submit your test data, code, output, etc. And these 3 files you have to submit for a program one. These are the 3 files. 1, 2, 3. Okay, data, input, output. Okay, something like that. So program, data, input, output, something like that. Input, output, one file, program, and maybe together whatever you said. 3 required. Okay. So this for the model 2, dual is minimization type. Constants are greater than equal type. The dual variables, everything same, but since it is equal type, with respect to the equal type, it is free. Okay. Now I'm coming to some problem. This already explained nicely. If you find any mistake, suddenly I am ready to explain. But we'll come to the example. Okay, see here. This is numerical example. This slide also I have given to you. So the maximization type problem, 2 constants, 3 variables, maximization type objective function, 2 constants, 3 variables. If I am solving, which method I will use? You have learned the method to solve such problem. Which method will you use? Tell me.
Big M method.
Yes. See, I'm telling here, big M method you should avoid. Why I'm saying you should avoid? Because you know when you go do calculation, once big is there, so it will create problem. When you write code, the big M is there, it will create problem. Okay. So try to solve this type of problem using two-phase simplest method. Two-phase. Okay. No artificial variables. No M, but artificial variable is there. Okay. So see here also I'm telling you if you are finding basic feasible solution also, this is a small problem, you can find solution. How many basic feasible solution possible? Because I don't know maximum number, how many will be there? Tell me. How many basic feasible maximum number? Say there are three variables, two equation. How many?
Three.
Three. All three can be or cannot be. That depends on basic feasible solution. So basic feasible means it fulfill the constraints and all will be non-negative. So what will do? First time I am taking x3 equal to 0. If I am setting x3 equal to 0, the first equation become x1 plus 4x2 equal to 100. Second equation become x1 plus 3x2 plus equal to 90. So 60-10 fulfills. 60-10 first equation fulfilled. Then second equation fulfilled or not? Anybody? Are you getting some?
Yes, sir. Fulfilled.
Yes, sir.
Fulfilled. So fulfilled,
Yes,
all are
sir.
non-negative, x1, x2, x3 non-negative. It is a solution. Then, so x2 make x2 0. Make x2 0. Okay. And solve. So x1 plus 5x3 equal to 100. x1 plus 4x3 90. So 50, 0, 10. Fulfilled.
Yes, sir.
Then second one fulfill 50. Also fulfilled.
Yes, sir.
Okay. So with respect to first and second, what is happening? So objective function value 60-10. So 120 plus 90, how much it is?
210.
120 plus 90, 210. With respect to second, how much it is? 50, 0, 10. Tell me. So 15 is 100 and it is 110, 210. Now, I am setting here if x1 set equal to 0, this is not there. If x1 equal to, because I have present the optimum solution. What if x1 equal to 0, what is the value of x2 and x3? Who can say? Can you calculate? Is possible?
Sir, x2 is equal to minus 50 and x3 equal to 60.
Very good. Very good. So once it is becoming negative, so it cannot be a basic feasible solution. It is a solution. So if it is not becoming basic feasible solution, I am not accepting that. Simply these 2 points. Okay. These 2 points are optimum solution. Okay. You got solution. So this is x1, x2, x3 are the primal variable. These two are the primal constraints. This is the primal objective function. And the extra is the optimal solution for the for the primal objective function. This. Now, what you can say from these two? What is the conclusion? See, I have told earlier, if you discover there are 2 points, 2 optimum solution, then the convex combination of this gives several. This problem has infinitely many optimal solutions. Yes or no? Many optimal solution. But here, these 2 points are basic feasible solution. Basic feasible solution. These 2 points are optimal solution. These 2 points are also extreme points because optimal solution occurs at the extreme point only. Basic feasible solution corresponds to an extremal point. There are 10 basic feasible solutions. So you will discover this problem has 10 extreme points. If a linear programming problem has, let us say, three basic feasible solution. So it has 3 extreme points. So out of 3, so here I am saying 0, 0, 0. Can it be extreme point? 0, 0, 0. Can it be extreme point? These are not in equation, it is equation. If I am saying this is less than or equal to 200, less than or equal to 90, then 0, 0, 0 fulfills. Okay?
Yes,
But
sir, for
this is
equality it is
fulfill.
not.
0, 0, 0 cannot be an extreme point. Please remember. Only it has two feasible point. Two feasible. Two feasible means the line segment. Okay, the line segment. One extreme point is this, another extreme. On the line segment, there are, if you say line segment, two endpoints are, one is 60, 10, 0, other is 50, 0, 10. So on the line segment, there are infinite number of points. Okay, put pencil mark and check like that. So middle point. What is the middle point? Who can say?
55, 5, 5.
Yes, 55. Then second component?
5.
5.
5. Third component?
Third one is 5. 5.
5. So 55, 5, 5. Now substitute here. 2x1, x2. 2x1, x2. 2x1 plus 9x2 plus 11x3. So x1 is 55. 2 into 55 kitne?
110.
110. And earlier 99 into 5, 45. 11 into 5, 55. That is 100. 110 plus 100. That is equal to
110.
210. You got another. So now from 2 I got another one. 3. Now instead of middle point, take some other point other than the middle point. Take lambda equal middle point means lambda. Lambda varies in the interval 0 and 1. So I am taking lambda equal to half. Take lambda equal to 1 by 2. Take lambda equal to 1 by 3. Take lambda equal to 1 by 4. Take lambda equal to like that. Several. Okay, easier. If you are writing code. So your Python program also you can say that yes, I have discovered several interior points. See, I am telling here. So now can you justify? So the point we have taken 55, 5, 5. Is it an extreme point? 55, 5, 5. Is it an extreme point?
No, sir.
It's not an extreme point.
Yes. Then you understood that. This only optimal solution occurs at the extreme points. So 55, 5, 5 is not an extreme point. Okay. See, you have to think in this manner. How many people say you are doing programming laboratory? How many are doing? All are they are in the class. How many are there? 100, 50, 30. See, I do not know whether your teacher is giving or not. Madam is taking your class, or have you seen madam sometimes?
Yes, so we've had lab classes.
Madam, see, madam was a student, I was a teacher. One professor asked me, he was doing a project. See, I'm not blaming you, or I'm not blaming, I'm just telling. So whatever you answer, you have to be cautious. One professor asked me, because he was doing a project, finally somewhere he find so a quadratic equation is coming. Quadratic equation is natural because when you do some solving the problem, the necessary condition or sufficient condition, you are checking, you got a quadratic equation. Quadratic equation, you got 2 roots, let us say. Then somebody asked, can you prove that it has 2 roots? Is there any chance that some problem it has 3 roots? So one quadratic equation 3 roots. Can you give example? Madam spent 10 minutes for that. Okay. So be careful, I'm telling. Okay. But I have given you the problem. I've given you the problem. What is the problem I have given you? I have given all the 10. What is that? All the 10 laboratory things I have given. Because generally those students are not attending class. The teacher will ask, what are the things covered? They will say nothing. So that is the reason I have circulated to everybody. That's soft copy. These are the program to be written and in a order. See, sometimes theory I have not covered, and we have reached to that level. Slowly, I will cover the theory. Theory in terms of the example. Okay. For example, there is a theorem Every basic feasible solution is in extreme points. And that proof is very interesting and very standard. Everybody understand. Okay, everybody understand. I will again give proof. Otherwise, so these things is incomplete. Recently, see, these slides I am writing, I am giving because I have written some documents for the book. My intention is to prepare a book for the IIT students community. I may not sell it, just I will, but it should be available online, free book or in my homepage. So I took the help of a director, because I thought if my book, the director's name is there, so possibly it will be attracted by IIT students. Okay, so I was testing. He immediately told, see, Dr. Bishwal, Professor Bishwal, I cannot contribute anything because I am too old. Okay, I am too old to contribute, so I cannot be a co-author. Then I told, he actually happened to be from my place. I told, sir, you are just like my elder brother. Your suggestion, your blessing for me. So certainly you should be a co-author. He told me, so I'm giving time. Sunday night we will discuss and mention the chapters, what are there, what are the topics to be covered, etc. will discuss. So before evening, he called me. No, he called me around 11 o'clock. He told me, see, if you are writing a book and if you have a co-author, your book should be #1 in the world. See, how can there are say crores of linear programming book? How can I say that I can write a book? So which will be #1, so that then he's asking me, you tell me why people should purchase your book. Then I told, sir, nowadays the machine learning is a basic subject everybody wants. So everybody wants to learn that, and linear programming, nonlinear programming, these are topics to be covered. So this time 400 students applied, but I could not help all. But if they like, I can give them the lecture note and I can teach them, but I cannot conduct class exam for them. So then I told, okay, you write things, okay, all right, but I was talking about my professor. So even some are the very good researchers, some are very poor researcher. So but there some are very good teacher. First, the IIT community, first we are teachers, then the researcher. Teachers highlight everything. Do you know? There is a book, this linear programming developed by G.B. Denji. You read the history, he passed away in 2007. And he has also checked the efficiency of the Karmakar's algorithm. So in his biodata he wrote, so he joined several, that time engineering was not there in his time, engineering is not at a different level. Only poor students were reading engineering, rich students are reading science because they want to discover something. So he told he could not find any interest in statistics or mathematics, that. So in the statistics, this linear programming, this somehow during the World War, so transportation of the community from one sources to destination like that, he formulated the linear programming models, but there was no solution. He is the person who developed the simplex method, G.B. Denji. You can read his biodata. So, and this subject becomes so popular, nothing is there in the linear equation, so popular. And he has written 2 books. So these are, I cannot say they are free, but I could download in some sites. So you can try volume 1 and volume 2 by G.B. Denji. Get some Mukunda, which I think one Mukunda is some, possibly he's from Nepal. Thapa, his surname is Thapa. So possibly Nepal or from India somewhere. So these 2 books, but a lot of theorems are there. Lot of theorems. So this cannot be covered in a semester. So you need a few semesters to complete. So these 2 books are there. So possibly in the reference I have given such 2 books are there. So but everybody I'll request, who knows that you will be also a good scientist, you will develop some algorithm, new algorithm that. So those are interested, please go through. Okay. So learning, there is no end. So, but if you're learning, see, research meaning is that whatever you want to learn, if you can discover something, yes, something is missed, something should be extra. So this is the research. Even one word, if you are adding the extra, okay. So I say that I'm saying 2, you should know that it's 3. Somebody said no, 3 is infinite. Okay. So even I'm saying people, there was question. Even I'm in your class, till I'm telling many people I'm giving this is the problem, have a solution. They should say it is 2 solution only, not infinite. So infinite because you have to believe. Say why it is infinite. Okay. This example 1. Now in the example 1, this is about the primal. What is the dual? Can you write the dual, please? Can you write the dual, please? Then we will verify. Please do it. Because these are the questions for you. In the test, these are the questions. So not this is these are the and suddenly, and you have to be careful and you have to do independently. But I will be happy if you can try. See, even I'm telling out of 30, if you are getting 5 maximum mark, whoever got 5, it will be the highest mark. Okay, please remember. But don't copy. If you copy, you will not be able to learn. Okay, you will not be able to learn. See, I'm telling you have software, you will solve the problem, write the answer. Say, for example, instead of 100, if you are writing 100.5, 100.23, what will do? Can you write the answer, whole number? You cannot. So it may happen also like that. So be careful, but whole number, because you have to use the table and you have to calculate. And see, this you need not use simplex method. Directly you can find solution. So since 2-3 variable problem, so simplex method you can use, or without simplex method also you can find solution, and it is visible. So this is a maximization type auxiliary function. The auxiliary function only for the dual minimization type. The dual auxiliary function is minimization type. Here, how many variables? 3 variables. How many constants? 2 constants. In the dual, there will be 2 variables. And how many constants will be there? 3 constants. And these 2 variables, since the constants are equal type, the dual variables are free. Okay, in this manner. Minimize type, this is maximization. With respect to maximization, it is minimization. 100 y1 plus 90 y2. y1 plus y2 greater than or equal to 2. 4y1 plus 3y2 greater than or equal to 9. 5y1 plus 4y2 greater than or equal to 11. y1, y2 are free. Free. Free means what? Free means what? Tell me. If nothing is mentioned, if I am saying y1, y2 are negative, how to solve this problem? y1, y2 are non-negative. How to solve? Which method will apply? y1, y2 are greater than or equal to 0. Let us say the 3 word is not there. If see the last line is not there, y1, y2 are free, nothing is mentioned. Nothing is mentioned means it is free. Please remember. If it is hidden, suppressed, then both are free. If, for example, I am saying y1, nothing is mentioned, but y2 is free. In y2, y1 non-negative, y2 is free. But here it is given both are free. Both are free means they can be 0, they can be positive, they can be negative. Okay. Now, say if suppose say y1, y2 are free and these restrictions are there, which method will be applied to solve the example? I'm just coming with some water. Please decide and tell me which method. Okay. See, if you cannot answer when I'm taking interview, you will struggle. And once you are not able to answer to any my question or that, unable to ask question also, so you will be nowhere. Please remember. Means you have not learned. You have not learned means your grade will be poor. I will not fail you. Please be sure. But your grade will be poor. P grade means it is a poor grade. Okay. P stands for poor, not pass. Hello, I've come back. So tell me, which method, who can say?
Sir, we can use two-phase simplex method.
How? How will you use? Because
Sir,
the two-phase,
artificial variables and surplus variables to make the inequality equality.
You are not attending my class, I'm sure. Anybody? Anybody from the ladies side? Ladies are punctual sometimes.
So
And
can
you
we
please
use
tell
big
your
M?
name and just okay. Tell me your name. If I want to hear your name frequently, then we are a good students, and I will ask you, and I will remember your name. Okay. Some Saurabh is there? Kya Saurabh?
Yes, sir, I'm there.
Yes.
I'm
Yes.
here.
Yeah.
So I was thinking we could use big M.
No. What is your name, please?
So Maitre Swaroop.
Achha, okay. You are from which place?
So I'm
Delhi.
placed as in department or where
Not
do I
department,
live?
but mathematics. Mathematics, you know?
Yes, sir. I live in Gurgaon.
Gurgaon. See, there was the professor called Kanti Saurabh. It's okay. So he has written a Operationals book. So when I came to know you are a Saurabh, are you related to Kanti Saurabh? Anybody?
Not that I know. No, sir.
Okay. No. Just I'm asking, curious to know. He in the very initial days, his book only available. Okay, it is still there in the market. Kanti Saurabh. Operation Cells by Kanti Saurabh. Okay. Okay, all right. No problem. See, what you do, there are how many variables are free? The two variables. For the two variables, you have to take these two. The first variable, the difference of two non-negative variable. Second variable, that is the difference of two non-negative variables. There are four variables. After transforming to four variables, apply any method, whatever is applicable. Okay, you will write y1. Okay, see, for example, this y1, y2, y1, y2. I'm making the order something like y1, y2, y3, y4. This is capital Y1, capital Y1, capital Y2. Capital Y1 equal to, which is free, small y1 minus small y2. Write down. Capital Y1 equal to small y1 minus small y2. Okay. And the small I1, small I2 are non-negative. Over. Then second part. Y2, capital Y2 equal to small y3 minus small y4. And small y3 and small y4 are non-negative. So what will happen? So this problem, instead of two variables, there will be four variables. And where small y1, small y2, small y3, small y4 are non-negative. So what will the auxiliary function? Auxiliary function will be 100 small y1 minus 100 small y2 plus 90 small y3 minus 90 small y4. Okay, similarly, the constant will be small y1 minus small y2 plus small y3 minus small y4. Similarly, you continue. And our variables y1, small y2, small y3, small y4 are non-negative. So all are becoming non-negative, constants are greater than equal to type. Apply either two-phase simplex method or big M method or dual simplex method. Dual simplex method will be covered soon. Okay, this. After finding the answer, our capital Y1 will be small y1 minus small y2. Capital Y2 equal to small y3 minus small y4. Okay, that's all. So if you substitute, so you will get the answer in this manner. Okay, same answer should come. Right?
So I have a question.
Yes.
So you said that.
Tell me, repeat quickly. What I said?
Sorry, sir. You said that we
Four
can
variables.
reformulate.
The two variables become four variables. This is consisting
Yes,
of
sir.
four variables. They are not the dual variables. Dual variables are y1, y2. So y1, see, I'm telling These two child, okay, these two child y1, y2, let us say, if I am saying two child, so there will be 4 child, okay. So first child's weight, the difference of two different, okay, small y1 minus small y2, okay. Second, like that, something like that. You think this activity, whatever maybe, okay. The two variables.
Yes, so we can apply the dual primal method once again on this new problem and solve that. So use that as like a sub procedure to solve the main problem.
Yes, because you hear, so I'm not solving, I'm telling you the answer. So if you solve, see, there are this problem, we have to solve either big M method, the converted problem, big M method, two-phase simplex method, or dual simplex method. Since there are 3 constraints, 4 variables, the problem will become bigger size. Generally, I am avoiding bigger size in my slide. Okay, this classroom. So bigger problems are good, but it is problematic. Okay, problematic. You know, we can solve. I could have given an example. So I am something I am keeping for the brilliant students, so that they can little be, you know, otherwise you will not think anything. See, you know that when you are a child, your mother at early morning you will give you food, at lunch o'clock giving you food, at afternoon like that. So her work to provide you food and you will feed you in by spoon. Okay. So after sometimes you will say no, I will take alone. Okay. Now you tell your mother you feed me. What your mother is saying? Will you, if you are sick then, if you are not sick, will you feed? You will not feed. It will already, you know, that phase is gone. Okay. So because you have taken the spoon, no, you give me, I will eat myself. Because you know, mother, when mother is giving, he's giving sometimes small amount, sometimes big amount. So you do not like. Now, when you use spoon, you want to take according to your desire, no? So I'm leaving you, you solve it according to your desire. Any problem? See, my examples may be sometimes absurd, but you try to realize why I'm saying so.
Okay, sir.
Okay. You can ask question, I'm happy. Because when you ask question, somebody is asking, somebody is replying. Okay. Optimal solution. My intention was to tell you some should be 0, some should be positive, some should be negative. Because if I am giving 3 and 0, or some example 3 and 2, so you will not believe that it is becoming a free variable, unless it will become negative. Negative, one of them negative, both of them negative. Okay. If both are positive, then earlier it was both positive, here is also both positive. Where is the free? Free means negative should come. Okay. So that it is an example, good example. So if I'm asking in an example of free variable, so you have to select this type of example, not that type. Here earlier it was non-negative. Here also non-negative. Where it is free? Okay. Now example 2. See here. Example 2. Is it that? A similar problem. Verify. 2 solution. Okay. I will not. So third one, suppose say which is left. First, middle one is suppose say 0. What is happening? X1 plus 4x2, 4x3 equal to 8. 2x1 plus 5x3 equal to 7. What is the solution? What is the solution? I don't have page here. Okay, you tell me the solution. Third basic solution I am interested. So if it is feasible, we will think. If it's not feasible, we will just leave it like that. What is the solution? Any negative is coming? X1 plus 4x3 equal to 8. 2x1 plus 5x3 equal to 7.
Sir, -4.
Negative coming?
Yes, sir.
Okay, then negative means once it is negative, so other basic feasible solution is not there. Okay, these two. So if it has 2 solutions, then it is sure that this primal problem has infinitely many solutions, because we are considering a type 2 problem. Is it a type 2? Constants are equally type. Is it a type 2 problem? Yes or no? If somebody asks, give an example of a type 2 linear programming problem, you give put. Because according to me, I am just giving name. This is a type 2 example, type 3 example, type 4 example. It is type 2 example. So with respect to this problem, we have the dual problem. What is the dual problem? See here. This. And this dual problem also, the y and y2 are variable, free variable. So if I am substituting in terms of say small y1, small y2, small y3, small y4, so this is my solution. Okay. And please remember, value of the primal objective function is also equal to value of the dual objective function. Okay. So that also fulfilled. Okay. So the strong duality holds here. Earlier example, 210. They are also 1210. Okay. So this is also the strong duality theorem. Okay. This. Any other example? Okay. This. Another example. Equality type. No, I am not giving inequal because it is equality type. So these two basic feasible solution. Which one is left out? You can verify these two. It has infinitely many solution. Okay. Again, in a negative. So many example. I don't know why. Okay. Okay, leave it. 1, 2 example is enough. Third. What is third? Objective function is maximization type. So subject to x less than or equal to b, constants are less than or equal to type, x is free. So what is the difference between first and third model? Who can say? Difference between first and third model.
So in first x was non-negative.
Non-negative. Here it is free. Means negative, positive, 0, everything permitted. Okay, this. If this is the primal, dual is that. This is the dual. With respect to a free variable, there will be a equality constants. This is the equality constants. Okay, this. Now, this problem, variables are non-negative. This problem, which method will apply to solve? Tell me. If a linear programming, let us say 3 variable, 2 constants or 3 variables are there. So if you are solving manually, how much time will take? 10 minutes, 5 minutes, 2 minutes? Because you are J student now. You possibly your calculation, you are calculating in very fast, in a very robust manner you calculate. So mine, I am committing mistake most of the time. You will not commit mistake because you have learned a special technique. Yes or no? Not that. Once you become old, so we like to make it fully correct. So and slowly we do because you want to finish and quickly and also correctly. And sometimes quickly if you do, mistake may happen. Okay. If you want to score quickly, in every over 2, 3, 6, then in fast over you will be out. Yes or no? If you want to score more, then you have to be very consistent. Every over you have to score something. Okay, right. Tell me which method? Anybody? Okay.
Two-phase simplex method.
Again, begin method, then two-phase simplex method, then okay, these two equality constants. Okay, all right. Begin dual simplex method we will not apply. If you are applying again, you have to convert. Okay, this. So now I'm going to some numerical example. The theory part is there, so why to unnecessary and lose your time? I'm coming to the example. Okay, this. Next one, next. See, here I will tell you, these are inequation. These are inequation, okay? For this inequation, how many basic feasible solutions are expected? If x1, x2, x3 are greater than or equal to 0. Don't make it free because we are looking for the basic feasible solution. So all positive means basic feasible. If one of the negative, then it is a basic solution only. So forget about x1, x2, x3. Only these two equations, they are in equation. One is less than or equal to 7, another is less than or equal to 8. So you have to add slack variable. If you add slack variable, then it will be equation. Then how many variables? Three variables and 2 slack variables. First, second, 5 and 5 equation. Now 5 variable, 2 equation. How many basic feasible solution? 5C2. 5C2 means what is that? 5C2. 5 into 4 by 2. How many? 10, no? Yes or no?
Yes, sir.
10 variables, 2 equation. In equation, I have to change slack variable to make equation. So out of 10C2 means out of 5C2, so there is 10. So I'm observing, let me say, maybe more, we don't know. So I am taking these 3 and negative. With component negative means 3 variables. 0, minus 11, 10, 10, minus 1, 0, 11, 0, minus 1. Okay. So all the cases, you know, everywhere it is become 59. 0, minus 11, 10. 0, minus 11 means minus 210 plus 290. So no, 11 into 21 minus. Okay. Plus
Minus
29.
231.
Because it is 21 into 11, not 10. Okay. Then the negative sign, then plus 29 into 10, 290. So as a result, we are getting 59. Second point also giving 59. Third point also giving 59. Okay. So it is given free. Free. So okay, all right. Free means positive, negative. We don't care. So that out of 10, we are selecting say 3, 0, 2 non-zero because 2 equations are there. So we'll get solution. And these are the free means some variables are negative and the value of the auxiliary function is becoming 59. Okay. Now, what is the conclusion? This problem has 3 solutions or more.
So infinite solutions.
Infinite. How to find infinite? To make a convex combination. Here, how will make convex combination? Tell me.
So we can take like one thing will be lambda 1, which will go from 0 to 1, and then there will be lambda 2, which will also go from 0 to 1.
I will tell you simple point, simple thing. Simply see. So 3 extreme points. Let us say. Let me say 3 extreme points A, B, C. These 3 points are, let us say, the corner of a, let us say, triangle. A, B, C. A is the first point, B is second point, C third point. Okay. Now, A, B, C. I want to prove that it is infinite. What do you do? So take A and B, join them. So any point on the line segment AB, it is also a solution. Any point on the line segment BC is also a solution. Any internal point, not any point. The extreme, forget about the extreme points. So the internal points, and similarly, any point AB, BC, CA. So you have infinitely many solutions. Okay, this way. Now it is dual. It is all are free variables. Dual is like this. Have you ever seen 3 equation, 2 unknown? Have you ever seen? Have you ever solved? See, now I told you, no, we find a solution if it is consistent and has solution. Here 3 equation, how will be consistent? 3 equation, how will be consistent?
So they will be linearly dependent.
Yeah, see, out of 3, one is depending on another 2. One of them is depending on other 2. They are not linearly independent. Okay. So what is happening? Simply in logic, first 2 I add. What is happening to that? Third one you got? First two you add. Y1 plus Y2 equal to 8. 3Y1 plus 2Y2 equal to 21. You add it. So 4Y1 plus 3Y2 equal to 9. So one of them you leave it and solve. Okay. So this is fulfilled. 5, 3 fulfill all three equations. Fulfilling or not? Tell me.
Yes, sir.
All three equations are fulfilled? Yes or no? And
Yes,
below
sir.
the auxiliary function 5, 3 means it is 5 into 3. 5 into 7 into 5. 35. 8 into 3. 35 plus 24. 59. Okay, that's all. Okay, so I want to declare something. So tomorrow 1 hour I will take. Then we have Monday class, Tuesday test. Before that, no, in this week, which day will be ideal? Which Saturday or Sunday? Saturday, I'm thinking Saturday we want to finish 1 hour. 1 hour, I think you can ask your query and whatever problem you're solving, and you can you'll tell me this is my problem, this is solution, okay? Or some problem you are facing or mistake this that. So whatever you find, you share with me, okay? Right? So Saturday, what is the date? Who can say? Saturday, February. बताओ 13, no? February 13, Saturday, 14, Monday, 15. Okay, 13. February 13. Okay, all right. 13, what time?
Sir, 12th is Saturday.
So 12th is Saturday.
12th.
12th Saturday?
Yes, sir.
Today is
13th Sunday.
Monday. So 5th is Saturday and 12th is Saturday.
Oh, yes. Sunday. See, once somebody is old, I don't have the calendar, that in the calendar, in the something is there the backside, okay? Okay, calendar is there, okay. Somewhere, I have to, where it is there? Wait a minute. Yes, 12th. Right? So 12th is Saturday, 13th is Sunday, 14th Monday, okay, right, 12th. So 12th, 8 to 9 is okay? Or 7 to 8? I think 8. What time your launch? It's a dinner, not lunch. You should not miss. What time? Tell me. 7 to 8 or 8 to 9 or what? Left or what?
8 to 9.
8 to 9 is, I think 7 to 8 is okay, or 8 to 9. After, or 9 to 10. 9 to 10 means this is my lunch dinner time, okay? Or afternoon. Tell me. Afternoon, you will move around for your tiffin, okay? Okay, we'll decide. Tomorrow we'll decide, okay? Well, I think it is 7 to, okay, 7 to 8, okay? Generally, 7 to 8 is ideal, okay? 7 to 8, Saturday. I'm noting down. Please note down. I send a mail. 7 to 8 p.m.
Sir, you're on mute, sir.
Sir, you are muted, sir.
Sir, you're on mute, sir.
Sir, you are muted.
Sir, we can't hear
Muted.
you.
Is it possible that you can mute my mic? Is it possible?
Yes, sir.
That type of thing you should not do it. Okay. So and to a young teacher you can always make some joke. We're old already. Okay. Okay. Where is the? Okay. Example 3. This is the example B, type 3. See, since they are x1, x2 are free, so I'm getting 3 points. Z star is 47. It has infinitely many solutions. That I'm not talking about. I'm talking only if these are free, then there will be equality constant. Okay, this another problem you can see here. Okay, but they are non-negative. Fulfilled. So another problem C. There are 3 points. See, first one is positive, all the components. Second one also positive. Third one is negative. But value of the auxiliary function is positive 135, and dual problem is like this, and variables are non-negative. Variables are 6 and 1. Okay, that's all. The last one I'll cover. Possible. The last one. So here what is the difference between the first problem and the last problem? Generally, the constants, for primal, it is non-negative, it's less than or equal type. Variables are non-negative. Less than or equal type, non-negative. Here, constants are equal type. Variable is free. Vector is free. Okay, this. And dual is like this. Primal is like this. And dual is like this. It is given constants are. So since it is y, with respect to equal type, which is the dual variables are free. Okay, here it is given primal variables are what? Primal constants are equal type. It is okay. So with respect to this, we have dual variables that are free. Constants are equal type, dual constants. So now let us see some problem. Constants are equal type, variables are free. So we are getting solution, 21. Some points are, some variables are negative. Here both are positive. First 2 points, third point. Okay. So what about the solution? How many solution it has? Yes. Infinitely many. And it's dual problem. See, dual is like this. Y1, Y2, Y3 are free. So it is actually by mistake one more has come. This Y3. This I should delete. Y3 is not there. Only 2, isn't it? Which section is page number 100? Okay, this Y3 is not required. Only 2 variable, no? 3 will come Y. 2 constants, 2 variable. This is Y3. By mistake it has come. Okay. So we find since they are free, so one is positive, one is negative. Okay. Next problem. You can see a similar problem. And it is earlier what? Equal type. Here also equal type. This is, terrible things. They are all becoming equality type constants. 3 equation, 2 unknown. When it will have solution? Tell me. 3 equation, 2 unknown. They have to be linearly dependent. Okay. So you can see. So how it is linearly dependent? So there you to multiply and multiply 2 in the first equation. and one with second equation. Okay, for 2i plus 2i 4y, 2 4 plus 1. 5. Okay, this is coming 9. Okay, this. Is all right? And last one you can see. If this is equal type, then it is free. And these are the problem, man-made problem. Man-made problem is based on theorem. If you are considering the problem like this, then you will have the dual variables like this. One more problem also there. Okay. So we'll stop here. So tomorrow we'll meet at 12. Okay. And Saturday, that is 12th February. Okay. Thank you. So I will stop here. And attendance, you know, if you are not attending the class regularly, so you should keep some application ready. Why you are not attending, you explain. Okay. Thank you,
sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.